Hello scholars, welcome back to the channel. Today we're going to be introducing one of my absolutely favorite topics in mathematics, and that is graphs. I love graphs. Next to algebra is my favorite topic, next to algebra, right? So what are we talking about when we say we're doing graphs, right? Well, the graph that we do at this level, we express on what we call the Cartesian plane or the coordinate plane, right? So this is the simple form of it that I have here, and I'm going to explain the different features of the coordinate plane or the Cartesian plane, which was named for René Descartes, who was a French mathematician. So the Cartesian plane has two axes. We have the x-axis, which is the horizontal axis, and we have the y-axis, which is the vertical axis. So we have a positive x-axis, negative x-axis, positive y-axis, negative y-axis, right? So usually the origin of the graph, which is at 0, 0, right here, the coordinates are given in terms of pairs, with the x value given first and the y value given second. So the two coordinates combine to give 1 point. Okay, so for example, if we are told negative 1 on the x, 2 on the y, we would move negative 1 on the x-axis, then 2 on the y-axis, and that's when we make our point. Not after the first movement, after the second movement. So it's a pair of coordinates. We call them the ordered pairs, right? Ordered pairs of coordinates. So we're actually going to be drawing this graph a little later on, but I'm going to run through some definitions here and also sketch some of the more common kinds of graphs, and then we'll draw this linear graph. We'll make the table, and we can also draw the linear graph. So the first point, a linear equation produces a straight line. The highest degree of x is 1. So these are linear equations. Y equals 3x plus 5, y equals 6x, y equals negative 2. All of those would produce a straight line. And the highest degree of x is 1. So we just have x to the power of 1. That's the highest degree. Even this here, in that equation, y equals negative 2, there is actually an imaginary x there, x to the power of 0, which is 1, and negative 2 times 1 is negative 2. So this is a straight line running through negative 2 on the y-axis, right? So the x coordinate would be 0. Alright, so these are all linear. A quadratic equation produces a curve, which we call a parabola, and the highest degree of x, or the variable, is 2. So we have x squared. That's the highest degree of the x in that equation. We could have x to the power of 1, but the highest degree is x squared, also x to the power of 0. The constant term represents x to the power of 0, which is 1 times the coefficient. So we have a constant term. So the quadratic equation will produce a curve called a parabola, and we'll see that a little later, right? Linear straight line, and it's named after line, linear from line, straight line. Alright, quadratic produces a curve. We have other kinds of graphs. You have the cubic graphs, you have the graphs of the various sine functions, for example, which will give some strange looking curves right? But at this level, we particularly are interested in the linear equation and the quadratic equation, the straight line and the parabola. As we go further up, we look at the sine and cosine functions, tan function, cubic functions, etc. Alright, so the coordinate plane has an x-axis and a y-axis, as I indicated there. 0, 0 is the coordinate for the center of the Cartesian plane, the coordinates plane. And we start numbering from 0 to each axis, from 0 out, right? So from 0 to positive infinity, from 0 to negative infinity on the x. So we would number them 1, 2, 3, 4, 5, or negative 1, negative 2. But we don't always have to go up by ones. No, this said the scales along each axis can vary. So when I'm saying 1, 2, 3, or 2, 4, 6, 8, or 5, 10, 15, 20, those are telling you the scale. How many centimeters, how many units per centimeter on the graph. Now the typical graph paper that we use is divided into 1 centimeter units. So if you are given a scale and you have to look to see if you are given a particular scale to use, they might say on the x-axis use 2 centimeters per unit. So that would mean 2 of those little small boxes, you skip 2 of those boxes before you write 1. And then 2 more boxes before you write 2. Because the scale is 2 centimeters per unit. Or if they had said 1 centimeter for every 2 units, then for each small box you'd go by 2. So you have to look what the scale is. Now the scale on the x-axis must be consistent along that axis. If you're going up by 1 on the x-axis, you must be consistent all across. Go up by 1 or go up by 2 or go up by 5. But you can use a different scale on the y-axis. You might choose to go up by 5 or by 1 on the x-axis. Your y values may be much bigger, so in order to keep the graph within that space of the coordinate plane, you might decide to use a different scale for the y-axis, where 1 centimeter represents a higher number. Because many times the x values are much smaller than the y values, many times. It all depends on the function, the equation that we're given, what we do to the x values to get our y values. And most cases the y values are much bigger than the x's. So we can use a wider scale on the x and a narrower scale on the y, because we have to fit all our coordinates on the page, right? So yes, but the scale along the y, the positive y and the negative y must be consistent with that axis. The scale along the x, the positive x and the negative x must be consistent. That is important. If you are not consistent with your scale, your graph will be skewed. It will not be accurate, right? And you should try to use the best scale that you can for your given values. So if you get small numbers, use a wider scale so the graph can be wide, so your readings can be more accurate, right? If you get small numbers and you use small numbers on the graph, a small scale on the graph, your graph will be confined to a very narrow space, and you might have to estimate some of your readings. So the more you can spread out your graph and use up your coordinate plane, the more accurate your readings will be. Because remember, many times we're asked to take readings from the graph along the x-axis or the y-axis for solutions, right? For example, simultaneous equations can be solved from plotting the 2 linear equations on the graph, or 1 linear, 1 quadratic, and see where the graphs intersect. And then we have to take our readings. So the wider we make our graph, the more accurate the reading will be. And we won't have to do too much estimating. Alright, now we talk about the domain and the range. So your domain is your set of x values, and your range is a set of y values. So usually you are given a domain, you are told let the x values be between this and that. So for example, for here I'm going to say let the x values be between -3 and 2, right? So I'm going to keep my graph will be between -3 on the x and 2 on the positive x. Your range will be the set of y values that you get after you plug your x values into the equation that you're given, into the function that you're given. Okay? Alright, now I'm going to just sketch some of these common graphs, typical graphs that you will see, so you have an idea, right? So I'm not going to put in all the numbers, I'm just going to put the relevant numbers and sketch the graph. It will not be accurate, they are just sketches. So the graph for y equals 4 is a straight line that cuts the y-axis at 4. And by the way, when we're given a linear equation or a quadratic equation, the constant term at the end will tell you where that graph will cut the y-axis. We call it the y-intercept. Okay? So let me write it here, the y-intercept. The y-intercept is that number at the end of the equation. The constant term at the end of the equation is the y-intercept. It tells you where the equation crosses the y-axis, whether it's a line or a curve. Now, y equals 4 is simply where y is 4. So let's say that's 4 on the y-axis. That line will cut straight across at 4. Y equals 4. Y equals -3 will cut across the y-axis where y is -3, straight across. Okay? I remember this is 0 at dead center, 0, 0. So let me put in all my origins. That's 0, 0. 0 on the x, 0 on the y. That's the origin of the coordinate plane. Okay. X equals 5. So on the x-axis, that's 5. So this would be a vertical line cutting through 5 on the x-axis. A vertical line. The y equals 4 or y equals -3 is a horizontal line because it's cutting the y-axis. X equals 5 is vertical, it's cutting down through the x-axis. X equals -2, so this is -2 on the x, so it would be a vertical line cutting down through the x-axis at -2. Y equals x. So the line that says y equals x, that means whatever y is, x is, right? Y and x are the same. So if x is 1, then y is 1. If x is 2, y is 2. So that's where they would meet. X is 3, y is 3, and so on. X is -1, y is -1. So that line cuts through the origin like that. The line y equals x, and usually we name our line or curve according to the equation we're given. So this is the line y equals x. It cuts through the origin. It's a slant line that cuts exactly through, halfway through the quadrant, halfway through the quadrant, through the origin. The line y equals -x would be the opposite of this line. So that means whatever y is, x is the negative of that, right? So that would mean if x is 1, y is -1. And if x is 2, y is -2. If x is -1, y is 1. X is -2, y is 2. So this line cuts the other way. Y equal negative x. So y equal x, that's the line. Y equal negative x, that's the opposite direction. Y equal x squared. So y equal x squared will cut like that. So this is the basic parabola. Okay. So we square the x's to get our y value, right? So if x is 1, y is 1 squared, which is also 1. X is 2, y is 4. X is 3, y is 9. So we'd have the curve going like that, through the origin and like that. Y equal negative x would go the opposite way then. So it will go that way. Okay. So y equal x, y equals negative x. X squared, sorry. Y equal x squared, y equal negative x squared. Alright, y equal x squared plus 2, it will be similar to the line y equal x squared, but we're going to move it 2 places up. Because remember we said the constant term at the end tells you where it cuts the y-axis. So it's the same y equal x squared, but it's shifting up to where y equal 2. So this is y equal x squared plus 2. Y equal x squared minus 7, it will shift down to negative 7, still maintaining that curve but shifting down, right? Y equal x squared plus 2, y equal x squared minus 7. Alright, so these are the typical graphs. You will have other variations, but these are the general types. And you should try to know these, right? Y equal x, y equal negative x, y equal x squared, which is your typical parabola for the quadratic. This is more complex, but it is the basic form of this. Alright, so let's write up the table then for this equation, y equals 2x plus 6. So when we're about to plot our graph, this is a linear equation, so we're going to get a straight line, right? As we do more videos on graphs, we're going to be doing combinations of linear and linear and quadratic by themselves, and you're going to see also how to solve simultaneous equations using the graphical method, how to read a graph, all of those things, answering questions based on graphs. As I said, this is one of my absolutely favorite topics, so you're going to see my passion coming out in this topic, even more so than the others. So we're going to set up our table of values given our domain. So the domain says for the x values starts at negative 3 and end at 2. Now when we're plotting a linear graph, we really only need 2 points. To draw a line, we need really 2 points. One here, one there, and we connect them, right? I like to also put in the 0 value to see where that's at. We don't need it, we just need the 2 end values. And you will see for the quadratic graph, we are going to need to plot every single point in between, well, from the end to the next end and all in between, because this will give us a curve. And we're going to need to connect all those points along the curve to make sure it's accurate. So we're going to need to list every point of the domain. For the linear graph, 3 points are sufficient. So the 2 end points, and I like to just throw in 0. You know how passionate I am about 0. Alright, so now we're going to fill in the different terms that tell us what to do to our x values to ultimately get our y values. So it says multiply the x values by 2. So we put 2x. then add 6, and finally we will get our y values. So let's multiply each of these x values by 2. 2 times negative 3, negative 6, 2 times 0 is 0, and 2 2s are 4. And we're going to add 6 to each of those. So negative 6 plus 6, that's 0. 0 plus 6 is 6, and 6 plus 4 is 10. So our pairs of values then, negative 3 and 0, 0 and 6, and 2 and 10. Those are the 3 points that we're going to plot to connect them to get our line. So negative 3, well, the highest y value is 10, so I'm going to give it a scale. I'm going to go up by 2 on the y-axis, and the highest x value is 3, so I can spread out the x-axis and go up by 1. Alright, so I'm going to say 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. On the y though, since I need 10, I'm not going to go up by 1, I'm going to go up by 2. 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. So when x is negative 3, y is 0. So this is negative 3 on the x, and since y is 0, we're stuck here. We're not moving from here because y is 0. Or when x is 0, y is 3. So this is 0 on the x, y is 6. 0 on the x, and we go straight up to 6. And when x is 2, y is 10. So 2 on the x, positive 2 on the x goes up to 10 on the y. And then we take our ruler and we connect those 3 points. And we should get a straight line. It's not absolutely straight on the board because, I'm estimating the scale. So now we're going to write our equation y equal 2x plus 6. That is our line. Okay, that's the line. So this is our domain value. This is our range. The set of y values that we got when we plugged in each x value into the equation that we were given, into the function that we were given. We did what they said we were to do. So our x values, they said multiply the x by 2 and add 6. And we did that. We multiplied each x value by 2, and then we added 6 to each one, and we got our y values. Then we plotted the set of ordered pairs with each other, the x's with the y's. Negative 3 to 0, 0 to 6, 2 to 10. And when we connected those 3 dots, we got our straight line. Not so straight on the board, but if you were to do it on graph paper, which is accurate, you would get your perfectly straight line. And remember, when you're doing graphs, you need to have your sharp pencil. We don't do graphs with pens. We use pencils for graph. Your pencil must be sharp and ready, pointed. Make sure you have your eraser, a clean eraser, and make sure you have a long ruler, preferably a transparent one so you can see below what's happening. Not absolutely must, but preferably. Right? So you must have your instruments sharp and ready for your graph so that when you're done, your graph will look beautiful. I just love to see graphs. Right? So, yeah, so we would plot our line. And we're going to be doing lots more graphs, answering questions on graphs, finding our values, solving equations on graphs, and all of that beautiful stuff. So if you have benefited from this video, you know what I'm going to ask you to do. By now you should know. I'm going to ask you to show your gratitude and your appreciation by simply typing, "Thank you, Miss." That's all I ask, is for you to type, "Thank you, Miss," to show that you appreciate me, right? And I would also appreciate if you would share this video to as many persons as you can so they can benefit too from the information that you just benefited from, right? If you have not yet subscribed to the channel, please do so now. Tell your friends about it, tell your cousins, tell your siblings, tell your classmates about this wonderful channel where they can come and set up their tent and they have all these videos to watch all day, every day for weeks and months. Tell them about it. This is a wonderful place to be, right? If you check the catalog and you don't yet see the video that you're looking for, you know, maybe you have that topic that you're struggling with and you just need some clarity, you need some light to be shed on it. If you're not seeing that video, just drop a line in the comments and let me know so that I can work on it. Eventually we're going to have all the topics covered. Don't you worry yourself, we have you covered, right? But if we haven't done it yet and you need that ASAP, just let me know and I'll do it for you. My beloved scholars, I'll see you in the next video. Take care.